Just make you stand up here a little bit longer. Come on, buddy. There you go. Okay, you should be good.
So, out of the probability of selecting a male or a favorable response, so you add 62 favorable responses to the 40 males of those, and then the 15 males of the 38 unfavorable responses, and that's out of 100. And then since there's males in the favorable responses, subtract the 40 from the sum of these, and then you get 77 out of 100.
Any questions for Ethan about how he got his numbers? Nice job, Ethan. So Truth is going to go over number 8, which was the parakeet problem. Truth.
You guys can see that? Oh, okay, cool. So the way I did it was I used the 25 blue parakeets, and I also used the 12 of the males, added them together to get 48 over 43. But then I subtracted the 10 male blue parakeets because it asked what's the probability of male or sky blue, and got 38 over 43. That's at least how I did it. So.
Yeah, come back. I have the answers to 6D and 9F. The answers are up on the board to those two. So 6D and 9F, the solutions are up on the board.
Where's paper in this book? Where's chapter? There's a big group of pages.
Are there other questions from the worksheet that you wanted to go over today? Grace? Number 2? So number 2 says the probability of a tourist visiting Indian caverns is 0.8. The probability of a tourist visiting the Safari Zoo is 0.55. The probability of them visiting both places on the same day is 0.42. Find the probability that a tourist visits either the Indian caverns or the Safari Zoo. So this was like the problem we did yesterday with the senior class being on the honor roll or being a varsity athlete. So we're going to use the information in like the formula. So the formula says the probability of A or B is equal to the probability of A plus the probability of B, and then minus the probability of both. So what information can we plug into the formula? Aaron?
0.8 is the probability of A, and then 0.55 is the probability of B, minus 0.42 is the probability of A.
Great. And in this case, we're looking for the Indian caverns or the Safari Zoo. So they're giving you the probability calculated as a decimal. So 0.8, you could think of that as like 8/10 or 80/100. So it's just written as a decimal instead of being like a numerical value out of a total number. So they're not telling us the total number of people. Instead, they're just telling us what the probability is calculated as a decimal. And Aaron, if we add the two together and then subtract 0.42, you get 0.93. So probability can be written as a fraction, but it also can be in decimal form. It could be in percentage form as well. So the probability that tourists visit either the Indian Caverns or the Safari Zoo would be 0.93. Other questions from the homework? Hey. What did you say, David? 6. Okay, I can't go over all of them, so can you pick one of the 4? See? So in number 6 it says use the sample space from 1 through 20. So think of like that you have a set of like 20 golf balls, and those 20 golf balls are labeled from 1 through 20. So our goal is to pick a golf ball out of a bucket or out of a bag. And part C says prime number that's including 1. So we need to think of all of the prime numbers from the values of 1 through 20. So Ko, what are the prime numbers that you have from 1 through 20? Did you say 2? 2? So those would be the prime numbers from 1 through 20, and they said including 1. So definition of a prime number is the number times 1, the number itself times 1, and those are the only factors of prime numbers. So in this case, how many prime numbers do we have up here? 9. So the probability of getting a prime number, including the number 1, there are 9 that we have listed out of 20 different options. There are 20 options because we're using all of the numbers from 1 through 20. The part next to it says find the odds. How do you find the odds? Caitlin?
Would you do 1 minus
Okay, so 1 minus 9 would be? What did you say? 11, 20 minus 9? Is that what you meant? 1 minus 9 is an 11.
No.
Oh, 1 minus 9 20ths?
Yeah.
Okay, sorry. Did you say 9 20ths?
I said 9 minus
Okay, sorry. You're quiet. Oh, come on. So 1 minus 9 20ths would be 11. So when you're doing odds, you're looking at the number that are for versus the number that are against. So there are 9 numbers that are prime out of the 20. There are 11 numbers that are not prime out of the 20. So odds is different than probability. Probability is out of total. The odds compares what you're looking for versus what's left over or what you're not looking for. These two numbers should add to be 20. Because essentially you're looking at the two complements of each other. Virginia.
9F.
So 9F says find the probability of not drawing a heart. So this is actually using complements. So if we wanted the probability of not drawing a heart, one of the ways we could work through this is find the probability that you have a heart. Thanks for laughing, somebody. Thanks. Is that?
Oh, that's adorable.
So, Virginia, what's the probability that you have a heart?
13 over
13
52.
over 52? That's not very good for you. No. So the probability that you have a heart would be 13 out of 52, or what would that reduce to, Virginia? 1/4. So if we want to find the probability that you don't have a heart, then we can use complements and take 1 minus 1/4, which would be 3/4.
Oh, sorry.
I said that as I was walking around. You just might not have heard me. Are there other questions?
This isn't really into this, but my calculator is charging in the back of my homeroom. Can I quickly go get it?
Sure.
Thank you.
Then you'd be interrupting the back of your homeroom.
Hopefully that she doesn't have class.
Oh. So today we're going to talk about conditional probability, and then tomorrow we're going to talk about multiplication rule. When I look at your notes, I have them flip-flopped. So on your assignment sheet is opposite of how your notes packet's listed. So I want to make sure that we're going through the notes in the right order. So we're going to do conditional probability today, and that should just be the next page in your notes. And then tomorrow we'll talk about independent and dependent events, which deals with the multiplication rule. So it is just the next page in your notes. Your assignment sheet is kind of just flip-flopped. So conditional probability, there's some kind of restriction given for conditional probability, or literally like some type of condition, some specific case that we have to look at. A specification is given for the information that we're trying to gather. And most of them are done off of charts. So there's a lot of probability that we can do when you're given like a survey or a chart of data. And in this case, it says, what is your most common, 3 days a week or more, form of school transportation? And today there are 26 of us, so we need to make sure our total adds up to 26 in the end. So the first option is you drive to school. Either your parent drives you to school or you drive to school, but not your friend, because that would be like the other option if you ride with a friend. So driving to school, either your parent brings you to school or you drive to school. Just the males, so I only want males right now. So Sam?
Wait, what if your sibling drives you to school?
That would be the other option.
Okay.
Okay, so Tyler, Sam, you're not raising your hand.
Oh wait, so I should probably drive to school.
What?
Nothing.
So does your parent drive you to school or do you drive to school? Okay, just Tyler. Okay, females. How many of you drive to school or your parent drives you to school? 4 or 5. Okay, there are 5. So the second option, males. How many of you ride the bus? 7. Does Timmy have his hand up? No. Females, how many of you ride the bus? 6, 7, 8. Okay, Sam, this was your option. So either you walk to school, you ride with a friend, you ride with a sibling, you take your jet ski
Timmy, you ever lifted your hand?
with all the rain we've had. Timmy, you don't have your hand up for anything.
I wanted to raise my hand for driving school. Please let's do the question.
Okay, so everybody has to erase because of Timmy.
Oh.
Oh.
Shit. Well, that's why I didn't write.
Oh, well there, good for you. And Sam is the only male that either rides to school with a friend or a sibling. So the total number of males we have would be 9, 10, and let's make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yay, good. Okay, females. One person walks to school too. Is
What?
How do you transport
walk to
yourself to
school?
school?
Wait, what?
How do you
Ride
go to
a
school?
bus, drive to school. I get
That's the
ridden.
best
Wait, I get rode.
Who drives you to school?
My dad.
Okay, so then we'll change this number up here to 6. 2 little changes. And then that's 2.
So
And that does make 16, so we should be good to go. So going across, 8 people are driven to school either by themselves or their parents. 15 people ride the bus, and then 3 people get here in some other format out of a total of 26 students in the class. So when you're looking at conditional probability, there's going to be a specific word that we look for. And in the first question it says, what's the probability that a student rides the bus given that the student is a male? So the word given is a way to give a condition or a way to state a condition or a restriction. So how do you think we would need to use the charts in the data to try and answer this question, Virginia? So she said, because of the fact that it's given, you're just looking out of the information, we're just getting the number of males. So on the bottom, instead of having the total of everybody in the class, we're looking for the total number of males. So our condition is the fact that you have to be a male. What goes on the top? You're not giving me a number, just explain, Sam, explain what goes on the top.
Students ride the bus.
The students that ride the bus. What else goes on the top?
That's not subtracted by how many students are male to ride the bus.
You're close.
Oh, maybe subtracted by.
You don't have, you actually don't need to do any adding or subtracting.
Okay.
Sarah?
It would be the male of the bus.
Right, so on the top would be the males, because we're looking at the fact that the student is a male and that they ride the bus. So the top part is the part where they're both occurring. The student rides the bus, given the fact that they are males, so they have to ride the bus and be male. And then on the bottom, the total is just out of the number of males. So in our case, we have 7 males that ride the bus. So the fact that they're a male and they ride the bus, that meets up right here at the number 7, out of the total number of males in our class, which is 10. So 7 out of 10 males ride the bus. So the given word means we're only looking for the number of males. So there really isn't addition or subtraction that we're doing. The addition that we're doing is tallying up the chart, but otherwise you're just kind of grabbing the correct numbers. The second question says, what's the probability of choosing a female given that the student drives herself to school? So here's the word given. The condition is that students drive themselves to school. Underline that part there. So we're looking at the students that drive to school. That's our condition. The top part then would be the females that actually drive themselves to school. So Caitlin, how many females drive themselves to school? 6, or get driven to school by their parent. There are 6 of them. How many total people drive themselves to school in our class? 8. So it'll be 6 out of 8, or what's that reduced to? 3/4. Any questions? So underneath it says these are called conditional probabilities because you need to find the probability under some type of restricted condition. And that restricted condition is after the word given. So it's giving us information that we're specifically looking at instead of looking at the classroom as a whole. There are 2 different ways that we can calculate conditional probability. We'll use the one today, which is exactly what I've tried to write in these little formulas above. So the conditional probability, the probability of B with a little line, and that little line means the word given. Yesterday we did a little hat, and that little hat meant the word not. So the probability of B given A has occurred is found by finding the probability of both A and B. So that's when you're going to look it up in the chart and find where both portions connect, the probability that they are a male and ride a bus to school. So that would be the and part. And then on the bottom is the probability of whatever's after the given. And in this case, it represents the A value. So whatever's after the word given, that's our condition, our restriction that we're looking at. And that's our total.
So does the line mean that B is given or A is given?
It's B given that A has happened. So the probability of B given A exists, or given A has happened, or given the information from A. The other way that we can find conditional probability is really just taking this exact equation and rearranging it, and we'll be using this one tomorrow, and solving it for the probability of A and B. So this will be the one that we use tomorrow. It's exactly the same equation, it's just rearranged. So sometimes we want to just know when A and B occur, and we can find that by taking the probability of A times the probability of B, again, given A has occurred. We'll talk about this case more tomorrow. So on the next page, you have two charts of data. Most of the probability with conditional probability is based off of the charted information. And we'll work through both of the charts of information, and hopefully we can get some questions answered. These are tricky because you really have to look at how the question is worded in order to kind of approach looking at the numbers we're trying to solve for the problem. So the first step, see if you can complete the table below. So adding the information, the columns and the rows. This is 9th and 10th grade students were asked in a survey whether they ever posted a video on YouTube. So it's divided up into the fact that they're male or female, and then the fact that no, they didn't post a video on YouTube, or yes, they did post a video on YouTube. Erin, how many, do you have the numbers for any of, do you have them all? What do you have? You're gonna go vertical first?
Sure.
What do you have for the nose?
For no, it's 510.
Okay.
Yes, 232. The total male, 422. Total female is 320. And the total, 742.
So when you're looking, an easy way to check to see if your values are correct, both of them should add to be 742. So horizontally, 510 and 232 make 742. Vertically, 422, 320 also make 742. So if you made a mistake somewhere, when you add horizontally and vertically, like if one of them doesn't match up, then you probably have a mistake somewhere in one of those columns. So not all of these are conditional probabilities, so that's why kind of looking at the terminology and seeing what the question is asking for. So the first one, it says, use the above chart to find the probability that a student posted a video on YouTube. So what information are we looking for or trying to use from the chart to find the probability that a student posted a video on YouTube? Mason?
Number of yeses over number of students.
So he said the number of yeses. So when we're doing probability, what we're looking for, and there are 232 yeses out of the total surveyed, and that would be 742. So Mason, that number reduces to
160 over
371.
Yeah.
So looking at the next one, a student surveyed was a male. So that means we're looking for the probability of getting a male in my survey. So Sarah, what would the probability of choosing a male that was surveyed? 422. Add a 742. So they're divisible by 2. We know the denominator is going to be 371. I bet you could do that with that calculator. Half of 422?
200.
Yeah, nice job. 211. Okay, so looking at the third part, it says the student was male and posted a video on YouTube. Yes. Say it again.
Oh, I was looking wrong.
part C, it says find the probability that the student was male and they posted a video on YouTube. So we're looking for the probability of being a male student and posting a video on YouTube. Is it?
Would it just be 118?
So 118, because 118 students said yes, they posted a video on YouTube and they are males. So that's the and part where it's meeting both conditions. What's the total? Say it again.
Sorry,
Ethan? Somebody?
I think it was 742.
742. So there's no condition because the word given isn't in there. We just want to know out of the people surveyed who was a male and posted a video. So 118 out of 742. Ethan, do you know what it reduces to?
59.
Over 371. So then the last question says a student was a male given, actually that's not the last, there's an E down there as well, given that the student posted a video on YouTube. So this is now our condition. So the condition is the fact that the student posted a video on YouTube. So we want to find the probability that they are male given that they posted a video on YouTube. So now after the word given, that's when our denominator changes. So what do you think, Sam?
232. Wait, no. Is that right?
232, that goes on the bottom
Yeah,
because
yeah.
232 represents what number?
That the total number of people that posted the video.
Correct. So the total number of people that posted a video on YouTube is this 232.
Over 118.
And then on the top would be 118.
That reduces 59 over 116.
And then he said 59 over 116. So now we're kind of pulling these questions together. So we're taking A, which was the number that posted the video on YouTube. B is the number that did both. So when we're doing conditional probability, the total that we're taking the number out of is 232, just the number that posted on YouTube. Out of, I'm sorry, on the top then is the 118, the part that did both. So then letter E says a student did not post a video on YouTube, given that the student is a female. So look for the word given. If you see the word given, that's your condition. So given that they are a female student. So the probability that they did not post a video on YouTube, given the fact that they were a female student. So what's the total number that we're looking for?
5. No.
The bottom. So what's the bottom number going to be? Somebody said it. 320. So the bottom number would be the number of females. That would be 320.
Oh.
The top number would be the females that said no, they did not post a video on YouTube. So no, they did not post a video on YouTube would be 206. So the both part goes on top. The total after the given goes on the bottom, and that would be 206. So it's and over whatever's after the given. And Sam, that reduces to
103 over 160.
over 160. Any questions? So if you haven't done so, see if you can go to the next question again, run through the chart. This is now talking about eye color. So green, blue, brown, hazel. Hopefully there aren't any other eye colors. Anybody else have other eye colors in here? Any purple eyes?
Red.
Red? Gray? I guess you could have gray. Yeah, that could be an option, huh? Excluded the gray-eyed people.
Better watch out for this. No.
So I have the vertical tallies or totals. Does anybody have the number of males? Virginia? 100? The number of females? it's also 100. And then just double checking when you add the four numbers on the total from the different types of eyes, you should get 200. So see if you can answer these questions. So the probability that a person has blue eyes is how many people have blue eyes?
100.
How many people have blue eyes?
44.
44. Out of how many people were surveyed?
200.
200. And if you divide that by 4, I know, tough question. 44 divided by 4.
11 over 50.
There you go. 11 over 50. So the second question says a male has blue eyes. This is the same thing of saying a male and blue eyes. That's exactly like the same thing, it's just worded slightly differently. Sarah, what do you think? 35 out of 200, which reduces to 7 over, you said 40, right? Yeah. So we're looking for the males, and they have the fact that they have blue eyes out of the total number of people we have to choose from, which is 200. Letter C, same type of question, except we're looking for females and brown eyes. So Nick, how many females have brown eyes?
38.
38 out of the total of 200 people in our survey. What does that reduce to? I think that's just divisible by 2.
Isn't it 38 over 100?
Yeah.
Yeah, that's what I'm
It's over.
So both of these are and questions. So male has blue eyes just means we're talking about the male and the fact that they have blue eyes. So very similar to up here, the student surveyed was a male. So we're just looking for the male students, and then right here, letter C says the student was a male and posted a video. So it's that and question. It doesn't say the word given, or it doesn't like specify that they have to be male. It's just male and blue eyes out of the total number. Or females and brown eyes. So I think this is what, 19 over 100?
Yeah.
So then the last one says green-eyed person is a male, or green-eyed person given that they are a male. So the word is, the word given, that then states our condition. So they're worded a little differently. So you need to have the both part on the top out of whatever's given on the bottom. Is that?
Would it be 27 because that's the green-eyed people, and then 100 because it's all males?
No, the males. So the green-eyed males are 27. The total number of males, which is our given information, not the condition, would be 100. And I don't think that reduces. Questions? So the very last thing that we're going to just briefly talk about would be the difference between a dependent and an independent event. If something's dependent, what does that mean? It depends on others, you rely on something else. So with dependent events, one event affects the occurrence of a second event. Or you could say it changes the outcome of the second event. And then there are two examples underneath. Just a parenthesis here. So it says a quiz during the week. If I gave you a quiz on Monday without teaching you anything, your chances of scoring well probably are pretty low. However, if I give you a test on Friday after teaching you all the material, then you should do well on the quiz because you've learned the material. So if I gave you a pre-test versus a post-test, or a pre-quiz versus a post-quiz, the probability changes as the week progresses or as you learn more material that would be on the quiz. The second example says drawing cards from a standard deck of cards and not replacing them. So if you take a card out of the deck and there are 52, if you pull one out, then you have 51 left. That's considered a dependent event because the stack of cards has changed. You have one less card. You started with 52, now you have 51. So that's a dependent event where the thing has changed. The other one would be an independent event, and it's just the opposite. So one event has no effect or change on the other event. And the information given here would be the probability of being a female and rolling a die or a 6 on a die. So just because I'm a female doesn't change my chances of rolling a 6 on the die. The second option, drawing cards from a standard deck and replacing them. So you take a card out, you look at it, for some reason you're going to put it back in the deck. So the deck isn't changing because it started with 52, and now it still has 52 after you pulled that out. So just looking at these examples below, all you have to do is say if it's dependent or independent. There's no work necessary. So 10 red chips, 5 black chips are placed in a bag. You choose 3 chips and don't replace any of the chips after they're chosen. So after picking one chip, the first chip, has the bag changed? If it has, it's dependent. If it stayed the same, then it's independent. What do you think for the first one? It's dependent. It's dependent.
We have to solve them.
You don't have to solve them. Nope, you're just saying is it independent or dependent. So that's dependent because once you take one chip out, you now have 14 left. When you take another chip, then you have 13 remaining. So the number of chips in your bag has changed. Number 2, the probability of selecting a student that has a driver's license and a student that has a dog. So does having a driver's license change the fact that you have a dog? No, they're just random events. They really have nothing to do with each other. So number 2 would be independent. So this one's dependent. This one's independent. And then the last one on there, it says Bill deals each person 1 card and then gives him or her a second card. What's the probability of getting a sum of 21 on the 2 cards? So again, you're not finding the probability, but would that be independent or dependent? Dependent. So once the deck changes, it's a dependent condition or a dependent probability statement. So we'll talk more about those tomorrow. Your homework, you have the answers. It's just on the bottom of the answer sheet. So the first 4 questions are not solving them, as is asked. No, you don't have to solve them. You're just looking at independent or dependent, and then it does say to explain your reasoning. Have an awesome day.
Right when you get the paper, just pass it back instead of like.